So let us just look at a couple of examples. One I can think of immediately is, let's say, lseek of fd comma 0 comma 0. What is that going to do? I'm saying please seek 0 number of bytes starting from the beginning of file, which means is the file position is going to land up here. So this is example 1. So this is the eventual position of example 1. So let's just write that here, mark that in this diagram. So we got the example 1, it reaches here. In fact, this is saying I want to read the book again, I want to go to the beginning of the file and start reading the pages. Or beginning of the file and start. Go to beginning of file or rewind the file. And this will always return a 0 because now we know that the eventual file position is 0. So this must return 0. You don't even have to check for that. Of course, it might return a -1 if your D itself is faulty. It's not a proper valid open instantiation. But since our FDs are not likely to go for a walk suddenly in the middle of a program, so we can expect that this will always return a 0. So let us write one more example here. Example 2 is lseek fd comma 0 comma 2. The second invocation, that is I'm saying from the these two from the end of the file I would like to skip by 0 bytes. So this is going to be the position, the file position is going to be beyond the last byte of the file, right? As if you had completely read the file. This is what it's going to be. And what is the return value of this? Size of the file, obviously, is the size of, because this is byte number 0, 1, 2, 3. This is actually byte number n-1, and where you are is actually n. Therefore, this returns the size of the file. So, in fact, this is one of the cheap styles of finding size of a file. Saying, no problem, just say lseek fd 0, 2, return value size of the file. If I saying, I'll give you one book, tell me the size of the book. You say, no problem, open the book, go to the last page, read off the page number. Of course, we'll tell you the size of the book in number of, you can always do that, no problem. If you say, I want to know the size of the file, you can definitely use this method to find the size of the file. But we find that it's not just the size of the file in which we are interested. After all, size of the file is only one of the aspects of the inode information. There may be other informations there. For example, we have this permissions. Shall we find out what are all the permissions which have been set for this particular file? Or timestamps. Can you find out when was this last time this file was modified and so on? So there may be some other details which are part of the inode information, not just the size of the file. Size only happens to be one of the informations. We may be interested in finding out who's the publisher, who's the author, see that all those details. That is not going to, just by opening book, going to the last page, you are not going to get that information. You have to look at some other place. You have to look at the inode information of the book, which says who is the publisher, what is the copyright, what is the price, maybe an important issue for a book, right? So that is the inode info we would like to do. This is what is known as the statistics of a file. It's called a file statistics or file status. I think status is a slightly better word. So the file status, the current file status. Obviously, size of the file is one part of that file status, and you may be interested in doing that. And there are two specific system calls which can tell you that file status. There is one stat2 and fstat2 system call which do that. Of course, the only difference between the two is stat operates on a descriptor. That means you already opened the file, and then on that FD you can operate using the stat system call. The fstat, of course, you don't need to open the file also. I mean, do we need to open the file to find out the size of the book? It's not required. Definitely, you can do that without that. This operates on a path name. So that's the only difference between the two. See, the first parameter is the descriptor in the case of stat, and a path name in the case of fstat. Rest of the parameters are the same, behavior is the same, absolutely, there's no difference. Both will simply read the inode information and transfer all these contents, which is what called the file status. That itself is a structure which is going to be transferred to the process data space. That structure is actually called the struct stat. And obviously, you need the structural definition before you invoke the stat and fstat system calls on a file management system. That structural definition itself, you are expecting it to find it in a header file called what is the name of the header file, which contains the definition of struct stat. Stat.h. Struct inode is in inode.h. You have to remember, you have to keep on discovering new header files. I got an opportunity today to have one new header file, so I'm giving you that. Stat.h. What I suggest is, why don't you read the stat2 manual pages in the programmer's reference manual? It's obvious. I mean, you have to read the entire manual, but today if you read that, probably these things will become clear, and how to use the stat system call to read the status of a file. You can always look at any path name and specify who's the owner, what are the permissions, what time it was modified last, when was it accessed last. All those informations you can just find out, and those are simply members of this particular structure. So that is a much more convenient. File size happens to be one of those members there anyway. ST underscore size or some nonsense member name, but anyway, those things you'll find in the stat.h. You have to open the stat.h to look at the members, or the manual pages, of course, lists the structure in a very convenient fashion. There is absolutely no problem at all. Okay, is that fine? So that is a more professional way of doing that. And of course, sometimes when you say I just want the size of the file, and a cheap way of doing that is to do this lseek fd, 0, 2, which returns the size of the file. Also is used. A lot of programmers use that. No problem. Now I'd like to look at the last call here, is the fcntl, which is short for file control. And of course, this fcntl call, the fcntl.h, of course, is a call which is part of the open family of system calls, that is file management system family. fcntl actually is used for a few different purposes. We can't discuss all the purposes today. I'd like to discuss only one of the purposes of fcntl. Is an afterthought on open flags. What I want to talk about is fcntl to be used as an afterthought for open flags. Like for example, there is one of your old files which you said, I want to open it. I said, I just want to write into my file. I'm not worried about reading about it. So you went and asked for, write only. Okay. And suddenly in the middle of the program, you decided and said, can I read a couple of bytes? FMS comes and says, sorry boss, you can't. It reads your file, but you never expressed the intention to read the file to start with, at open system call. So open flags, if you want to make a change to it at a later stage within the same program, of course, one way of doing that is you close the open instantiation and reopen it with the new open flags. But that is a bit of a bore, to close it and open it again and come to the proper page in the book and so on is a big problem. So what we would like to do is, can we make a change in the open flags as an afterthought so that it can take effect from that point onwards?